Hello everyone, welcome to the third lecture of our game asset creation. Today we have exciting news that Unreal Engine 5 Early Access is available and I'm really excited to go through it and test it together. Honestly, I think it's 2 hours ago that they announced that this version for the early access is available freely, and I planned that today we can use it as a part of our tutorial series, and I think it would be very fun to test it. Just maybe wait for 1 or 2 minutes more, and then we will start our lecture. Okay, just first let me ask, can you hear me easily, and is there any problem about the noise or problem with the sound? Just let me know. Okay, great. Thanks for answers. Yeah, perfect. Hi everyone. Yeah, let's go through the next gen of the Unreal Engine and see what will happen. I already downloaded the version. You can either go for accessing the source code and build it yourself, or download the pre-built version. As you know, there are lots of information about the new version, and also they gives us access to the scene that they shown in the introduction video. However, it's more than 100 gigabytes, and yeah, it will take time for load, and I did not have enough disk space to download it. But it's very interesting if you download and take a look at that version also. Let's launch it. If you have the Epic Game Launcher, you can easily open it and download the new version. It's comes with the new logo, and if you checked, they also changed the design of the U in the new Unreal logo. It's more circular now. When you open it, you will find out that the launcher is also a little bit almost totally changed. If you take a look, you have the access to the previously opened project or all of your project that you previously test, and also you can select other type of project to create a new project. For example, now we would like to go for the new project as a game one, and when you select it, you have access to the default templates. One of the new things about the templates, today we are not going through it, but it's interesting because it's the topic that I'm working is the new virtual reality template that I'm really interested to test it. They implemented new system, and also OpenXR plugin is already available in there. But for today's project, I suggest to go for the third person template, and we will call it stylized stylized lantern UE5. The type of the project that we would like to work on it can be either blueprints similar to before, or C++. That we select C++, that in case that we will have enough time, we will also try to write some codes in there. The target platform is desktop, and quality is maximum. Starter content, I will also use them to show you in case something. And ray tracing, I will deactivate it. At least from my knowledge, from the previous version, it took time to compile a shader for ray tracing. Otherwise, we can also go through it. I did not test it honestly in this version, but I will test it in a short while. For now, let's deactivate it and press create project. It will take a time because first of all, it should copy all of the starter content pack and also compile some part of C++ code. But we can wait. In case if you have any question or Yeah, something to discuss, just write in chat. Otherwise, yeah, I will wait a little bit that project opens. And meanwhile, I can also open the previous things that we already created. As you remember, we already created a texture set for our lantern, and also we exported the mesh that we will plan to use it in Unreal. Yeah. Okay, it's going to load. I will remove things that I do not need. Perfect. Yeah, welcome to Unreal 5, and by the first look you can see the totally new design UI, and I'm really interested about it because yeah, the previous version was old style, and this one at least it's a very clean UI and also the modern yeah, UI style design. Yeah, much more cleaner. And one of the things that I really like about it is if you if you remember the previous one, you always have the need to have the content browser here, and it covers a part of your screen. But now you can easily hide it, and by pressing Control Space, you can access it. It makes your environment much cleaner and easier to use always. And also about the other things. However, I'm the former Unity user. For in that case, I always put the word outliner on the left-hand side and the detail tab on the right-hand side. But the default setting is not like this. One of the things that I will start is I will open my Rider project because it will take a time to indexing all of the C++ classes of the engine, and I would like to do it in background. In meanwhile, let's we are talking about the main things. If you have some experience with the previous version, you know that the third person example is something similar to this. It's nothing, almost nothing is not changed, but the point is, if you go to the edit project setting and search for Lumen, you can find out that the global illumination by default is active by Lumen here, and also the reflections. It means we can get benefits somehow, benefits of the Lumen even in this simple scene. However, my graphic card is not supporting the RTX features, but even in that case, they mentioned that Lumen should work. And we can easily find out that even by moving the lights, we have we do not need to bake the light anymore, at least. The other things that is important, I highly recommend if you are using, let me just press trust. If you are using Unreal Engine and you plan to write your code using C++, I highly recommend to use Rider from the JetBrains company. It has lots of reasons to use it, but in general it makes your workflow much faster. And in case you already install it, if you go to the editor preferences, inside the source code, you can select the Rider from drop-down menu of the source code editor. Usually afterward you need to restart your engine, but because I have it from before, it's already active for me. And whenever you would like to open it, you can come to the tools, open Rider. However, there are also other ways to open it. Similar to before, if you want to play in Unreal Engine, if you want to test your game or play it, you can always press play or press Alt-P to test it. And if you want to test only the physics in your game, for example, the create menu now is here, and if you create a simple sphere and put it upward and activate the physics, and you only want to check the physics of this object, You do not need to go to the play mode because sometimes it's difficult or it's not your the things that you want. You always can press Alt S or pressing the simulate to only check the physics simulation here. Okay, let's dive into our topic. We would like to know how to import our created game assets and applying a material and giving it some functionality. In this way, I open the content browser. Again, in this version, you can press Ctrl Space to open it. I create a new folder, call it stylized lantern UE5. Usually, it's suggested to call it the same name as your project, and the reason is afterward when you import other maybe packages or other objects from somewhere else, as using migrate or importing from the Unreal marketplace, it's not going into your own project, and they will create separated folder, and this makes your workflow much easier. And here I will create some folders with some numbering. Usually I put 00 as maps, and then one for blueprints, the other one for models, and the third one for materials. For this project, I also plan to have one folder for VFX or FX. However, I am not creating FX, I am only using one of the Niagara templates, but yeah, I think it's good to have it. Let's save our scene, save current level as, and then stylized map, third person lantern test. Okay, now we have our map that's saved. Maybe this will makes our workflow easier. Now we will go to the models and create a folder for our lantern. If you remember correctly, we already exported our model from the Substance Painter. I just drag and drop my model into the Unreal. The import setting is a little bit different, but not that much. The main difference is now we have the button for build nanites. That's absolutely for our model is not reasonable. We made it with old workflow that we baked light map and other stuff. But the important point is for this object, we need to press combine meshes. Otherwise, it will create separate mesh for each part of our model. As much as you have separated objects. The other things, I do not want to import material, do not create material. You can press it and deactivate the import texture. I do not want to import texture in this way. And select import all. By importing your model, and also if you want, you can also dock your content browser, but I do not like it. If you double click on it, you can see your model in separated window. It has no texture, but you can already see the UV. We made our UV in somehow automated way, not very precise, but it works for us. And yeah, I will just anchor it here, and let's go for the next things. The other things that I would like to import is the textures for this object. I will go to the exported texture and select them and import them directly into the folder. One of the good features that I like about the Unreal Engine is it's automatically somehow recognize the texture type. For example, this texture is normal map, and yeah, it's recognize it because it needs to change some setting accordingly. And the other things that's important, the storm icon here. Unfortunately, I did not have time yet to test nanites, but at the end of this lecture, if you have time, we can also do that. Yeah, it's free of charge. The other things that I would like to test, because I heard that if you press create, or no, not this one. When you want to import something, you can directly import from Quixel Bridge. That we should test it together. Yeah, we can test it at the end. Yeah, here you can import directly from Quixel Bridge, and we can test nanites there. Okay. Yeah, we have our texture. When you see this star symbol, it means they are not saved. By pressing Ctrl-Shift-S, you can save all of the assets that is not saved, and you can see them. Otherwise, when you plan to save your project or close it, you can use them. We have our textures. One of the difference between the Unreal and Unity is Unity by default has a material that you can use it and or assign the default textures. But in Unreal, you should create your default material. And it doesn't matter because in both cases for such a this object, for such a this importing feature that we are creating our custom material, it's better to learn how to make your own material. Then let's go to the materials, and here I will create a new folder, call it Substance Painter, because maybe you need more than one material from Substance, and you can put all of them here. And right click and select material. Usually in Unreal you try to use some letters or some prefix to distinguish between different objects. For the material, it's suggested to use M underline, and we call it Substance Painter Base. It's our base material. By double click on it, you can go to the material editor windows. It seems that they did not find it, got a time to change the design of the editor, but I think they will change it because it's a old style of the Unreal Engine. But yeah, it's not important. The material, creating the material needs maybe hours of lectures, and I'm not going through it in deep, but the only things that we need, I try to cover them, and if you have any question or would like to know anything about them, just ask it and we can discuss about them. As I mentioned before, one of the nice features is the content drawer that is available everywhere by pressing Ctrl Space. And now when I go to the models, lantern, I can access to the textures that previously I imported. I just drag and drop them here, a little bit organized. Yeah, perfect. The first texture is our base color. I told you the difference between the base color and albedo is the base color does not contain any ambient occlusion detail. It's only the color. If you would like to add the ambient occlusion, then you should go for the next texture map that we created last time. If you remember the name of this texture map, you can also check it here. It's occlusion, roughness, and metallic. It means the first channel, that is the red channel, is ambient occlusion. If you connect it to the ambient occlusion, it will assign that ambient occlusion information into your model. If you deactivate it and activate it again, you can see a small difference in there. And almost the ambient occlusion is the grayscale map that will multiply with your base color. You can also use the blend multiply to do the same things. The next map is the roughness that you can connect it. If you forget it, always check the name of this texture, and it says that's again occlusion, roughness, metallic. And the third one is the metallic map. You can easily see now our object is reflecting and the metallic part is look metallic. However, the wooden part is also reflecting so much. We should either go to Substance Painter and solve this problem, or here we can take a value from the roughness, multiply it by a value by pressing 1 and by holding down the 1 key on the keyboard, and then clicking you can create a float. Float is 1, vector 2 is by holding 2 and vector trees by pressing 3. And then right click, convert to parameter, and I call it roughness control. By default I put it on 1, but yeah, we can control it later on. And it means everything that we have in the roughness map will be multiplied with this value. If we increase it, if we put something more than 1, the roughness will increase, and our map looks much more rough and less. Yeah, absolutely, it's more reflective. If I connect it directly to the roughness, the problem will be that the value for the roughness can even be more than 1, but roughness value should be only between 0 to 1. In that way, I use the clamp value and then connect it to the roughness. Now, by changing this value, you can easily see that's what's happening. By reducing it, it's more reflective, and by increasing it, it's totally rough. For now, I will put it to 1, and we will check it later. We can do it also for metallic, but I think for the metallic it should be okay. However, it's a good practice to also duplicate it. The duplicate in Unreal Engine is Ctrl W. It's different than usual duplicate, but don't matter. Also, I will connect it and call it metallic control, and I will connect it to the metallic. The other things that you can do, for example, you can select them and assign some groups to them. I will say is control, and here this one also control. And I will put this one into the I will define it as a parameter and call it ORM, or occlusion roughness metallic, and define it into the maps or textures. Convert to the parameter base color in textures. Yeah. The next map that we have is the normal map. You need to only connect it to the normal. You can also flatten this map and define your own value for the normal map, but I just defined it. I just keep it like this. And by assigning it, you can easily see the influence of the normal map on your object. And the third map is our emission map. If you remember that we defined the emission for the light part of our lantern, and I would like to connect it to the emission color. But first of all, we define it as white to be able to control the color of this. It's a very good point, because if you multiply it with the color, by holding down the number 4 on your keyboard and clicking, you can create a color, and then I will convert it to the parameter and call it emission color. I define a group for it separately as emission, and default color, I think something like this should be fine. If I connect it to the emissive color, I should be able to see the influence somewhere in the model. I hope so. Yeah, it's this part. It's some part of our UV that is emissive. But I would like to also have control over the amount of this emission. In this way, I another time multiply it with the value of vector and convert it to parameter and call it emission power. By default, I will put it as 0, but I can connect it to the multiply and then emissive color. When you can see when this value is 0, that it has no effect on this part, and if I put it, for example, on 100, it's totally doing the emission. For now, I will keep it on 0. And the reason that I convert all of this parameter into the all of these scalar values into the parameter is to be able to change them according later on using the material instances, and I will show you. And you need to only create this shader or this material one time, and after that you can change it using material instances. I also convert this into the normal map and convert to the parameter and call it emission map. I assign them into the texture groups. Yeah, perfect. Now just save your material, close it, and come back to scene, press Ctrl space and go to the materials. The material that we created is here. We can directly use this material, but I highly recommend to create material instance out of it, call it mi, and according to the object that you need, stylized lantern, for example. And then I will put it inside the model, beside my model. In this way, I have all of the related object to this object, to this mesh into the one folder. For me, it's easier to handle it in this way. Now I select it, and if I go to my objects, and here inside the materials, I can change the material, either search for mi stylized lantern, or because I already selected the material, if I select the use, press the use button, it will assign that material to my objects. And you can see all of the things that we already assigned is available here. Let's save this by pressing Ctrl Shift S, and let's put it into our Word. Okay, yeah, first of all, it's too big. I would like to have it something like this, yeah. And let's see the influence of the material that we already created. By double-clicking on the material, it will open the material instance window. Let me scale it down to see them at the same time. Yeah, I really searched that they've also considered maybe putting these windows somewhere that we can see the model and window at the same time without overlapping. I hope they do this later. But if you check, you can see that the parameters that we defined and the categories that we defined for them is available here. It makes our workflow much easier. For example, by increasing the roughness, you can see we can make our object more rough, or by reducing it, our object is more reflective. I think putting the value of 2 is good for this object. Yeah. And again, for the metallic control, by reducing it, it becomes plastic instead of the metallic, and by putting it to 1, yeah, it's more metallic. The emission color, you can access here, and you can change it. And the emission power, you can easily change it in this window. The reason that is very important to have this parameter here is that we would like to have the blueprint out of this object. And using this parameter, you can control the amount of emission, and it would be very fun. I will keep it 0 for now. And also, in case you would like to create another material, you need to only create another material instance and only replace the textures. And it's very now simple and easy to do all of these things. Okay, let's close that. But let's think what could be the usage of this lantern. The usage of this can be as a checkpoint in our game. that when our character cross this object, the light will turn on, and yeah, some other effects will be available. Yep, always the autosave is also possible. To create the blueprint, to create this functionality, we can go in two ways, either for Blueprint or C++. I will start by Blueprint because it's faster and also easier to do as a prototyping. But later on, if we have time, I will also go through the C++ structure and try to do this using the C++. I think it would be fine for this lecture to do both of them. The other thing is, usually if you want to know when do you should use the blueprint and when you should use the C++, the important point is blueprints is not as fast as C++, but it's not that much bad. It means if you do not have a repetitive things like the update function or in Unreal Engine the tick function, you can already use the blueprint, and it's much easier and also more convenient to use. But if you would like to use something so much repetitive, I highly recommend to go for the C++ code and do it in there. Okay, let's go to our content browser or content drawer inside the blueprints and create a new blueprint class. When you click on it, you have access to different type of the blueprints. If you are a Unity users, you know that usually you can create a game object, and game object also the game object code. But in Unreal Engine, they divided such a that phenomena into some separated part according to the usage, and I think it's very interesting. For example, if you have only one object that is not controlling or possessing by the controller, you can use actor. But if you would like to move or possess that object using the controller, you can use pawn. And if it's exactly your character, you can use the character class and all of the other things. There are lots of different type of blueprints that you can create. For us, is only the lantern that is not controlling using the controller. In that way, we will use the actor class. Blueprints usually it has the prefix BP as blueprint, and we will call it stylized lantern. By double click on it, you can go to the edit menu of this blueprint. I will assign it here. And you see, yeah, some of the shapes are already changed since UE4, but yeah, almost everything is similar. Just by default, you have default scene root. If again you are a Unity user, you know you have some component in Unity that you can attach to your object, and in Unreal you have different components in the same way that you can attach to your blueprint. The first thing that I would like to have is the main shape of our lantern, and by adding a static mesh actor, I can do that. And I will call it, yeah, let's keep it as a static mesh, the name. The static mesh is already added as a child of this scene root, but I would like to have it as a parent object. By clicking and dragging on that component, it becomes the it becomes the parent component of this blueprint. But it doesn't show anything because we did not select any mesh for it. We have two types of meshes, static mesh and skeletal mesh. However, there is none that I think it's counted as a static, but I should double check whether it's already static or it's a separated class for it. But in order to assign the static mesh is a mesh that is not changing the shape of it in a runtime using the skeletal mesh or the shape keys that you can define, and the skeletal mesh is a mesh that you can change or deform it using the deformable component like bones. The static mesh, you can come into the detail panel and select the static mesh that you would like. stylized lantern, and it will import your and it will assign that static mesh to this component. Okay, that's perfect. If you come back to your main screen or the main window, and you select the previously added object or static mesh and place it in a word in the place that you would like to have it, and when the blueprint is selected, right click on it, go to the replace selected actor with, you can replace it by blueprint. Absolutely, you will not see any changes in the scene, but already it's changed to the blueprint, and any changes in blueprint will assign also to this object. The idea that we had is by crossing this lantern, the light should turn on. In this way, we need a component that enable the triggering this event or triggering the overlap event. The component here is we will use the box collision in this way, and we can call it overlap component. If you move it in your scene, you can see it's a box. It's small for us. I will increase the size of it, bring it upward. You can always look in different views and easily set it according to your need. I think something like this should work for us. Now, what's the usage of this box? Absolutely, it will trigger our events, but because when you go to the collisions, the collision preset is overlap all dynamics. If you open the collision preset, you can see it will overlap with everything that collide with this object. All of the collision response for this object is overlaps. And also the collision enable is query only. It means no physics collision. It means it will not react according to the physics. It's only triggering that event. And the object type by itself, it's board dynamic. In order to test the functionality of this, we can come to the events and press on component begin overlap. By pressing this, we'll move to the event graph. That you can see the begin play, actor begin overlap, the tick events, and also the component begin overlap. The difference between actor begin overlap and component begin overlap is that this one is connected to this component, and actor overlap is connected to the whole actor. In Blueprint, by dragging this execution node and releasing it, you can assign a new function, or by pressing space or by right-clicking and typing the function that you like, you can also access it. But using this will give you the context-sensitive features that is more useful. I will type print to only print some string to test it. Light is triggered. And I will change the color and the duration to the 10 seconds. It will print on the screen and also on the log. As you see, you have access to different data related to that overlapping component, but we do not need it. For example, if you want to check whether it's the character or other stuff, you can use the other component and check it either by tag or by class and other stuff. If you are familiar with them, in Unity, it's almost the same concept here. By pressing compile, you can compile it, and but just press these 3 dots and unsuccessful only to save and compile at the same time. I just compile it and it's already saved. Let's test it whether it's worked. I will go to the viewport play again, and by crossing this trigger area, you can see the light is triggered, shown on the screen, and it means we already did our job correctly. Great. But the idea that we had is to turn on this light. How we can do that? I would like to do this in this way. Maybe you have other ideas, but yeah, it's my style. You just feel free always to follow your own style. I will get the static mesh by clicking and dragging and getting the material of this static mesh. The material index is 0. The reason for the 0 is if you open your model, you can see you have only one material, and this material is element 0. It's exactly this value that you can see here, element index. And you can uh, you can create dynamic material instance out of it. I will connect the begin play into this, and because I would like to do it on the begin play, and the target will be again this static mesh. It will create a dynamic material instance for me that I can change later on. And the return value could be assigned into the another variable that I will use it later, and I will promote it into another variable, and this variable will be called dynamic material instance, and then dynamic material instance. You have it here. If you select this I, you make it public, and you can see it also outside of this class, but I do not need it. I will use it only here. Perfect. Now we have access to this material. We can say, okay, this gets this dynamic material instance and set the scalar parameter value. And the scalar parameter value will be the value that, if you remember, for this object, we had this emission power. And this value can control this emission power. I will type that one, emission power. And the value, I will also promote it into the variable and call it light emission. Also make it publicly available to see it also outside this class. The default value for it, by pressing compile, you can access to the default value, and light emission, I will put it on 100. I would like to see it very clearly. And yeah, if you check your class again, you can see here the light emission, you have access to it. And now we are setting the parameter. Oh, it's not one. We are setting the parameter name emission, the parameter with the name of emission power, the value of 100 after overlapping this component. Let's test whether it's worked. Perfect. You can now see by crossing this lantern, we are turning on this light. However, you can also deactivate it after crossing it, but the idea is it will be some kind of maybe checkpoints that every time that you're crossing it, it will be turned on, and it will stay also turned on. Very good. Now you have control over the amount of it, and also you have control over its behavior. The next thing that I would like to add to this object is some visual effects. But before that, let's add light. I like to have a point light with much less intention radius, and exactly in the middle of this lamp. I increase the power of this light and I will use the temperature for it to make much warmer light. As you see, it's turning out our environment. I increase the source radius a little bit to make the shadow border smoother. If you sorry, if you increase the source radius, you can see your shadow is getting a little bit smoother. However, we are not using the ray tracing. With the ray tracing, it's much better result you can get. And the other things that we can check here, yeah, I do not want to see this by default in game. In that way, I will check hidden in game. It means when I play the game, I cannot see it. It's great because I can test it before the starting of the game, and in a game mode it's already deactivated. But I would like to turn it on whenever I turn on the emission. In this case, I will go to the event graph, grab the point slides, and set hidden in game to the false. You can see the value, it's false. Now, if I press play, and when I cross it, the light will also turn on and I will get some influence from this light. Perfect. Okay, let's see. Let me just check something. Okay, not this one. Yeah. Indirect intensity. I can also increase that. Okay. Yeah, the next thing that I would like to also add to this, it's some visual effects of some particles around this light. In order to do that, I will go first to the FX folder and create a new folder inside it and call it hanging particles. One of the new particle system that Unreal introduced maybe 2 years ago is the Niagara system. In order to create that, first I need the Niagara emitter. However, I can directly create Niagara system, but yeah, I prefer this way. I create Niagara emitter and I will select new emitter from templates. Here I have one template called hanging particles. What the Niagara emitter is doing is similar to the particle system, with the difference that yeah, it has some more advanced feature, and also in Unreal 5 these features is already expanded much more. I call it NE Niagara emitter hanging particles. Just open it. If you check, you can see, yeah, you have this hanging particle, and I can control the color of them here. I would like to have a little bit yellowish particle, and I think it would be fine. Something like this. Perfect. Again, if I right click on it and create Niagara system, I can have a system. I cannot use it directly in Niagara emitter. I can use it in the scene, but I cannot use it inside my blueprint in a way that I want. I need to create a Niagara system, and I will call it NS Niagara system hanging particles. This Niagara system is almost the same as what we created, just we have control over the Niagara system properties. Okay, I think I did not save that one. Yeah. And now, yeah, I have the influence of them. If you want to test them, just you need to drag and drop your Niagara system, and you can see it becomes available into your scene. It's very nice effect. But I would like to have it inside my blueprint. In this way, I'm coming into blueprints, and it's static mesh, and I select it to as a parent, and just I will create a Niagara particle system as the child component. You can always add here then a Niagara particle system because I already selected it. I move it upward and move it inside the lamp. Okay, that's cool. And again, I can activate and deactivate it in game, but I would like to spawn this Niagara system whenever I cross it. It means I do not want to immediately turn it on. I would like to do the spawning process of this system. Yeah, it looks much better. In this way, I will come here and spawn Niagara. Let's check how does it. Right, spawn system at location. Using this node, I can select the Niagara system that I would like to create. I can define the location of it exactly at the position that I have it. However, I will hide the main one because I do not want to see it from the starting point. I will get the location of this component and assign it into the location. Again, I would like to have the same scale as my main actor, and I will get also the scale of that. However, you can also assign it as child of that object to see the same influence. Let's check whether it's working or not. Okay. Mm-hmm. Let's see. Yeah, perfect. Yeah, great. Now you created already the particle system, the mission influence, and also changing the material. You can use all of these settings in all of the objects that you create from Substance Paint, create from Blender, and texture from Substance Painter. Almost our lecture is done, but using the blueprints. If you have any question until this point, let me know. Otherwise, I will try to demonstrate some part of this functionality in C++ to see how does it work. Okay, great. Then let's create a new C++ class. In this version, you can go to the tools, new C++ class, and create your new class. Our class, similar to our blueprints, will be the actor, and I put it in the public folder to distinguish between the header file and the C++ file, and I will call it interactive, or I will call it checkpoint. By pressing create class, Unreal will create resources for this one, the header file and C++ file, and put it accordingly into the corresponding folders. Let's just create them. You can see also the progress here. If you checked the Unreal introduction for the Unreal Engine 5, there are also some updates related to source controls and related to the merge conflicts. I hope it will be somehow useful related to the blueprints, but we should test it with our Git workflow to test whether it's useful or not. But they mentioned they make the team workflow much easier. Okay, our C++ class is created, and if you go to your writer, you see your class, the C++ file, and the header file. By pressing, by going to the game and the source and the folders that we mentioned before, you have access to these two files. First of all, let's take a look at the header file. In the header file, you have some includes. That is, the main one is the core minimal one, and the last one is always that class that generated, that always should be the last include. Otherwise, you will get compiler error. We have some public methods that is the constructor of this class, and some protected one that is begin play, and again the other public one that's tick, that you can deactivate it. But I will put this tick function inside the public, because yeah, I will use this public for the components that I would like to create. If you remember, the first component that we create is a static mesh actor. I will create that again using the U property. The reason for the U property is if you would like to create some component that is visible also in a blueprint, or any parameter, or any array scalar, everything that you would like to see in your blueprint, you should use the U property. And it's a macro that Unreal is already defined with lots of functionality to create very interesting things. Inside the U property, you have some options or parameters to define. One of them is the accessing modifier. I will use edit anywhere. It means I can modify the content of this parameter or this variable, either inside the inside the scene view or inside the blueprint itself. The other things I will write blueprint read and write to be able to modify it either inside the blueprint or inside the C++ code. However, we do not need for most of these objects, but I just write it to know about it. And I will define a category for it and call this category as a feature, and call this feature as a component. Now it's time to define our component or our variable. Our component is a type of U static mesh component, and we should create it as a pointer to this class, and we'll call it a static mesh component. Now, by going to the C++ file or pressing Alt-O on keyboard, you can go to the C++ file of this object. Inside the constructor, we need to create that component. In order to create that, we will again call static call that variable, and using the create default subobject method and defining the class for it, we can create it. And we should define a name also for it, because yeah, different object needs different name. It's important when you're automatically creating several objects or several components using the script to define also the separated name for them. Otherwise, it sometimes makes a problem. Static mesh component. And I will assign it as a root of this blueprint or this class by set root component static mesh component. Okay, let's build it to see what we have. Press Ctrl Shift B or the build button or any other way that you like, or even go to the engine and press the compile. In the new version, the compile button is here. After a short while, you will see that the process of building is already finished. However, you should wait. Yeah, you will also hear a beautiful sound that is a little bit positive. It will show you that your work is already done. And if you go to the C++ classes, you will find out your class here. And if you go to the blueprints, you can create a new blueprint from the class of checkpoint based on the checkpoint class, and I will call it BP checkpoint. I will open this blueprint to see what we have here. Absolutely, it's empty, but as you remember, we already created this static mesh component, and we can again define the static mesh or assign the static mesh to it to create exactly the same things that we had using the blueprint. I will put it in scene. Oh, I will scale it down. Okay. The next functionality that we can add for this object is that overlapping feature. And I would like to add it using either a little bit with the help of blueprint or without help of blueprint. If you would like to add it using the help of blueprints, you can again come here and create a blueprint overlap event. And if inside your code you created new class, I create a new public one using new function micro to be able to access it also inside the blueprint, and I will call it blueprint callable. It's the method. It's a void and on component unbox overlap. I will call it unbox overlap. Yeah, but the other things that we need here is that box component. Then let's create it. View property. Let's exactly copy this part and then called view box component. When you use the rider, it can automatically add for you the necessary includes. Yeah, in this way, I will try. I prefer to use the forward declaration. Let's just give me a moment. Box component. I will remove this include, and if I press this hint, I can add a forward declaration, or by pressing Alt Enter, it's easier. It will add for you the forward declaration to this class. And now when you go to your C++ file, you can create it. It's a box component. It's a create default subobjects and view box component. Box component. But you see that error comes up because we did not define, we do not have access to that class in the C++ file. We did just forward declaration. Now by pressing Alt Enter again, we can include that necessary library, and now we can use it. Box component that set attachment, and we can attach it to the static mesh components. Let's build it. Okay, let's see what's the problem here. Oh, yeah, absolutely. We did not implement this method. By pressing again Alt Enter, you can implement that method. Let's build it again. Now I have that component here. I can see it, and again I can scale it up. Oh. Make it similar to what we have for the other one. Yeah, again, all of the settings is similar because, yeah, we created from the same default class. Inside the event graph, if I drag this and unbox I have access to the unbox overlap. It's very good because now we can easily use the blueprints to trigger this event and use C++ to run the remaining parts. This part is almost nothing to run. It's very simple for the blueprint to cover it, and this part can be very maybe expensive to run, but because it's C++, it's much faster than blueprint to run. And here, in order to test it, I will use the gengine dot add on screen message and using the layer -1 and 10 seconds of showing. Whenever you forget what you need, you can always press Ctrl Shift Space to see it, or just go to the information for this function. The first one is the key, the second one is time to display, the third one is color of that text. I will use the maybe blue color, and the third component will be the text that you would like to show. String printf, and you can use text macro, and we can say box component is overlapped. Okay, perfect. Let's just build it again and see whether it's working. Okay, I hope everything is working. And let's see what's the problem with this object. Okay, it's not triggering this event. Oh, yeah, absolutely. We need to begin overlap for the box component, not for the static mesh component. Yeah. You could see I will do it again, and I will move it here. When we cross this lantern, this method will start to be triggered, and unbox overlap method will call from C++. And the text is shown up. Perfect. Yeah, we almost create what we have from the blueprint. We can repeat the same structure inside the C++. For example, we can, if I remember correctly, and begin play. Let's first create another call it feature lighting, and let's create access to that dynamic material instance. Dynamic material material instance dynamic, and lantern material dynamic instance. If I remember correctly, it should be from the static mesh component that create material dynamic material instance. What's the parameter for this? Index element is 0. The source material is 0 again. Yeah, I think only with the index element we should be able to create it. Lantern dynamic material instance, and let's see whether it will work for us. Okay, now if you see now we have a slot for this lantern material dynamic material instant, and when we press play, if we select this BP checkpoint, yeah, perfect. We have access to that material as a dynamic material instance. Now our work is very simple. On box overlap, we just come here and lantern material instance and set a scalar parameter value. The things that it needs is the parameter name. That is the, yeah, we can define it like this. Parameter name, what emission power, and the value. I will define another variable for it. It's the property and it's from lighting, and the value for it is, it's a float, call it emission power. By default it's equal to 100, and yeah, usually you need to do this like this, and use that value here also. Perfect, let's test it. Yeah, great. Now we are able to do the same functionality that we had here using the C++. However, we already add some additional feature for that blueprint, but I think it's it's almost the same. If you like, we can extend these lectures in future by going in depth into all of that functionality. I'm also looking forward for them, but I think we need to finish this lecture today. Let's, at the last point, just test that Quixel bridge feature that Sebastian asked. In meanwhile that I'm trying to access that, if you have any question related to this lecture, just ask in the chat. Otherwise, I'm trying to add that object from the Quixel bridge. As I read, we need to log in again with our Epic account, if I remember the password correctly. Great. Yeah. Now I need to download this object. And I should be able to drag and drop into my scene. Yeah, it's trying to preparing the static mesh. Okay, where is it? It's preparing textures. Maybe for the first import it should take a little bit more time to also compiling the shaders, because it's importing the textures and creating substance. It's creating the Quixel base texture. I think, yeah, it's creating that one. But let's see, how does it work? Building mesh distance field. Wow. Yeah. It's very huge. I think I should scale it down. The initial resolution should not be the final one, as they told. It will load it progressively. But yeah, let's see how does it look. For now, it's not very high it's high resolution, but yeah, and yeah, that's perfect. Let's see the nanites visualize and triangles. Oh, there is no nanite triangles. Hmm. Doesn't seem that's. Hmm. Okay. Hmm. Um, did not create the nanites by itself. It's interesting because it seems that it should create by default. I just select it right now. Mm-hmm. And let's see if I come here and select nanite triangles. I don't see anything. Let's try this with other assets. Content, bridge. For example, I will download this one. I will add the asset again. Is there any option project setting related to the nanites? Yeah, my fan is almost exploding. Nanites. The quality is very good, but I think the nanite is not working at least on this object yet. Maybe I should, yeah, I will double check the workflow and maybe we can have another, yeah, stream about that. You're right, it's very noisy. The quality is awesome, but I'm not sure yet whether it's nanites or not. But the quality is really good. Okay, great. I think we should finish this lecture and I will test the new systems later on. Yeah, I'm not sure because they showed in some tutorials that it's already working, at least in their presentation of the Unreal 5. They talked about it that it's already available but at least I cannot see it right now, and I don't know why, but yeah, it's not working, at least for me. However, this from the size of the file, the object, it seems that it should be nanite available because it's a two millions of vertices, and yeah, it's theoretically from the very high quality assets. But yeah, yeah, but I'm not sure why. For example, it doesn't show anything from the nanites here. Okay, thank you so much for joining this lecture. If you have any suggestion or any things that we can extend our lectures with, that just let me know. I'm really glad to have these three parts of lectures together, and I'm looking forward to see you again. Thank you very much, and see you next time. Bye.